Joined, sir.
Yeah. So before that, I'll just give you one simple thing. Say a ball is thrown from the ground to the Earth's surface. Ball is thrown with the initial velocity u. Okay. So obviously the velocity keep on decreasing. At the topmost point, the velocity becomes zero, and then it'll turn back, right? So until it hits the ground, so we can call this as x-axis, the vertical axis, or you can also call it x. So let me call it as x. So for this motion, plot x versus t graph. T is on the
Yeah,
T is on the horizontal axis, and x is
yeah.
on the vertical axis. So x versus t graph of this motion. How will it look? Let's try.
Yes, sir.
Got the answer?
Almost.
Yeah. So until it reaches the maximum height, it will look like this.
Root or h by 2g.
No, no, the graph I'm saying x versus t.
Okay.
Is this clear? And what is this curve? This curve, what is it? What type of a curve is this?
Um, this is parabola.
What is the difference between this parabola and this parabola? This is a parabola. What is the difference?
It's increasing parabola and that's decreasing parabola.
Yeah, one is inverted u, other one is u. And this inverted u, the slope is decreasing. See this parabola, the slope initially is high, after that it will decrease. At the topmost point, it becomes zero. Okay, here this parabola, initially the slope is high, at the bottommost point, the slope is zero. Okay, and slope of x versus t curve is velocity. Okay, so while going up, the velocity is maximum here. After the velocity keep on decreasing, right? That's consistent with this slope. Is that clear?
Yes, sir.
So slope of x t curve is this one. So u parabola, the slope is zero at the bottommost point. After that, it's increasing. The inverted u, it's opposite. Slope is zero, and then it becomes steeper and steeper. So while going up,
Yeah,
it's inverted u. Yeah, inverted u, but this part from here to here. Okay. While coming to its u, starting from this point from here to here. What I want to say is, see, this thing is x versus t curve, and trajectory is path of the body. So this path of the body is like this. So it's going up, and then it's coming in the same line. But for the sake of drawing it properly, I'll show like this. I'm going up, it's going like this. While coming down, it's coming in a slightly different line. So this is called trajectory, which is the path of the particle. This gap is artificial, which is not actual. This gap here, it's not real. Actually, the gap is not there. Understood? No? It's going
yeah.
up one vertical line, coming back in the same line. Okay? But just for the sake of understanding, we should get small gap. So what I want to say is, what if I know this xt curve, I don't have to say anything else. From the XT curve, I should get this trajectory. One way to do is squash this curve on the x-axis. You will get this curve.
Yeah.
Okay. So to
Yeah.
get a XT curve, trajectory, just pull this up. This point of the trajectory is t equal to 0. This point is t equal to some value. This point is t equal. So this point you push it to t equal to t1. Here, this point you push it to t equal to t2. This the t equal to the maximum height point. This point you push it to t equal to next t5 or t6. And if we join all these points, we'll get the XT curve. Okay, so XT curve, you squash it, we'll get a trajectory. Trajectory, if you expand it, we'll get this XT curve. Okay, so so this is the actual XT curve. So I can define velocity between 2 points, this point and say this point, by taking how much x is covered, delta x, in how much time, delta t. Okay, so that delta x with delta t is the average velocity between these 2 points. Instantaneous velocity means I just go to that particular point and take a very, very small interval.
Okay.
So that will become velocity at the instant t1. Average velocity is like between t1 and t2. It's defined over time interval.
Oh,
This delta x between that interval t1 to t2 and the corresponding time interval t2 minus t1, because t2 is higher. But instantaneous is defined at all instants. It's like saying you have 10 marks, 10 tests. One way to get the idea is to have average of say 4 tests, or I can take the individual test marks to get to understand how the student is performing. The individual test marks are like instantaneous velocity. At each and every point have the velocity. Average is like a overall performance. That also got meaning, right? Because I just have to know, figure out only one number. If taking the progress report to the principal will not have time to see each and every test, but she will just see one average and see whether the student is good or not. Okay.
okay.
Similarly, average is
Okay.
like, so that way, fine. That's the basic thing. So this is a complicated motion, say x versus t. Okay, the x is increasing. Okay, and after 2, it's decreasing. Okay, and at time t5, it has come to the original position. And after t5, it's going on the negative side of the x-axis because x is negative. And after t6, it's turning back. Okay, and at 7, again it reaches the origin. Okay, or you can say the starting point. And after t7, it's again moving towards the positive direction. So this is t curve. For this curve, if you have to get the trajectory, I just have to squash this curve on the x-axis. It will look like this. Not able to figure out?
Yes, sir.
Yeah, yeah. What I want to say is,
What, sir?
yeah, yeah. So whatever says this xt curve is there, no? The corresponding trajectory for this motion is this one. Okay, so this curve is basically this xt curve. You squash it on this x-axis. Is that clear? So the maximum height point will be x2, which is the maximum point reached here. Okay, so average velocity between 1 and 2 is this much delta x between 3 and 1, x13, and the corresponding to t13. So x13 by t13 is basically slope of this line because it's a right angle triangle. So the slope of the secant between the corresponding the time interval is the average velocity. Instantaneous velocity becomes the slope of the tangent because it's different at any point, each and every point. If you want to find the instantaneous at t1, I should take a very, very small interval of length dt, the corresponding displacement will be dx. So this is dx by dt. This line will become a tangent at this point because this dt is very, very small. So instantaneous velocity is slope of tangent at that particular time instant of xt curve. So this is one important thing to realize. Okay, this is slope of secant. Is that clear?
Yes, sir.
So average between any two time intervals. So similarly, I can define average between 1 and 2. You have to find the corresponding t12 and x12, and x12 by t12 is this one, average velocity.
Yes, sir.
And average speed is different. You have to take the path length traveled between the two time instants. So it will be 1 to 2 and then 2 to 3 divided by the time. So distance between 1 and 3. And the
What, sir?
corresponding average speed is distance covered between 1 and 2 or whatever test time, t1 and t3, divided with the corresponding time. Distance between 1 and 3 is entire path length, 1 to 2 and then 2 to 3. See, distance between 1 and 3 is this much distance from here to here. Okay, but distance between 1 and 3 is, you have to calculate the full thing from 0 up to the starting point and then come back here. Correct? No. So distance between t1 and t3 is from here to here, which will be more compared to the displacement between 1 and 3 in this particular example. So speed average will be always more than the velocity average because distance is always more than the displacement. Okay, distance and displacement is only at one case where there is no turning back. Here there is turning back, no, at point 2. So that way the distance will be more compared to displacement. But instantaneous velocity is defined as the dx by dt, which is the slope of tangent. And instantaneous speed does not have independent definition, just the magnitude of this instantaneous velocity.
Okay.
Okay, so that instantaneous speed is defined slightly differently. There's no independent definition. It is matter of definition. And that previous thing,
What?
just a minute.
Which one?
Wait. That problem home to market, we didn't finish it, no.
Oh, yeah, yes.
So what we figured is from going to home to market it takes 30 minutes, no? While coming back at 20 minutes. That's right. Yeah. Time taken by the man to go from home to market is half an hour, which is 30 minutes. And to come back from market to home, it's 20 minutes because while coming back, the speed is high.
Yeah.
While going to the market is going slowly at 5 kilometers per hour. While coming back, it's going faster.
Yesterday we did this. 0 to 40 minutes, 0 to 50 minutes till that I did.
Yeah.
0 to 40 minutes you have to do now.
Yeah. 0 to 50 minutes, the average velocity will be 0 because it's reaching the same point. But
Yeah.
average speed will be the distance which is 5 kilometers divided by 50 minutes. You have to convert to seconds. Average speed 5 kilometers.
Now the third one we have to do 0 to
Yeah.
40 minutes.
So 0 to 40. So 30 you would have reached the market. So remaining is 10 minutes. which is half of 20 minutes. So it will be the middle point. Because he is traveling at uniform speed. There's no acceleration here. Constant speed. What answer? What is the average velocity? And
Average velocity, I got 6.625, correct?
1.86375. Displacement is 1.25, no?
Oh, oh, okay, I did it wrong. I do 1.5 instead.
No, how come 1.5? You would have come halfway, no? Because when
Just a
turning
minute.
back,
I'll calculate now.
yeah.
1.875, correct, sir?
1.875.
Now using that average speed,
You have to take the path length. For average speed, you have to know the distance, which will be the 2.5, no? One way. 2.5 plus half of 2.5. 2.5 plus half of 2.5 is 1.25. So total distance will be 3.75. That divided by the time. Correct?
yeah, got it.
Yeah.
This question was easy compared to the rest.
Compared to
Compared to the rest of the questions.
okay. Do you have extra time to study and all? Like look for extra
Yeah, they give.
questions. In case actually Chaitanya material is big only, you won't have extra time. But in case you want to find the latest questions, you can search in YouTube. You just have to type NEET PYQs, kinematics or 1D motion.
Your YouTube channel, did you post about this, sir?
I'm I should be more
I saw your YouTube channel. That's good.
okay. Previously you've not seen?
Huh?
Previously you've not seen that?
Which one, sir?
My YouTube channel?
Yeah, I have seen few videos.
No.
The
You have seen now only or previously itself? I told you
no,
that
no, no,
time.
no. Now only. Yeah.
No.
Like that time, I didn't know what your channel name was. That's why.
Uh, this in your in C IPL, there was
Yeah,
one girl, Swati, no?
yeah, I know, I know.
How much did he score in 10th standard?
I think somewhere around 490 something.
490, is it?
Yeah, the topper was Pradyumna. You know Pradyumna, sir?
The girl who next sits with her?
No,
Right.
Pradyumna's guy.
Uh, oh,
Yeah.
that
The
guy.
guy who scored 497 in midterm. Yes.
No, there was one guy who used to study Alak Pandey.
Yeah.
That guy.
That guy.
How much did he
The
score?
topper was 492. The
What about
topper was Tanushrago.
Madhavan?
Madhav Krishna.
No, Madhavan.
There is no Madhav.
There is one guy. I saw him near my home also.
Madhav Krishna, like
Okay. The guy who's in
is
the
I know
What
Madhav.
about Hari Prasad?
Hari Prasad. I don't
Short
know.
guy.
I don't know him, sir, unfortunately.
Hmm. But they were saying Max was tough paper.
Yeah, the initial paper was yes.
Which paper?
First board. First board.
Okay.
Despite that, I got 471.
Who got center in maths?
I think neither of them did due to that 5 mark.
Oh,
Yeah,
this what is the maths teacher name? Short guy.
I think it's yeah, it was.
Coordinator.
Sorry, I know. His
What
name
is
is
his
Surya
name?
Narayan. Yes, Surya Narayan.
No, no, no.
Then
Telugu guy only.
Yarni
But
ma'am.
he
No,
is the coordinator, man. IPL coordinator.
IPL coordinator.
The guy
Murthy
from
sir. Murthy sir.
Murthy sir.
Murthy sir.
Where is he now? He's in 11th standard or 10th standard only?
He's in Palaram one down stand.
11th standard, no.
Yeah,
So who is someone new has come for 10th standard.
I think so. Yes.
Hmm. Okay, okay.
So after you left, sir, things have gotten difficult for us. For
Hmm.
me especially.
No, this Gayatri one has gone and complained. She was getting less
Oh,
marks, no, compared
yeah,
to say previously. She'll be the topper and Harshan will be second.
yeah,
No,
yeah. Arsenal is the top and she is second.
huh. After I came, Harshan was first and she was second.
Yeah.
So that she didn't like.
Yes. So when you came, before you came, I used to score very less.
Ah,
After you left, I scored even more less.
okay.
Unfortunately, yes.
What are the other students saying after I left?
Few people miss you, few people don't.
Yeah, yeah. See, even in IPL also the same situation. Um, See, the problem is, I'm not saying I didn't make a mistake. The mistake I made is I did not control the class. They were talking.
Yeah,
So MPL also a little bit. Gayatri keeps on talking. No,
sometimes,
Gayatri and who was
not
the
always. Sometimes.
no, no. My class she always talks because I don't I'm not strict. So she always talks and then she gets scores less mark and then she complains.
To be honest, this was the reason I like this. Sir.
Okay, it's good because I don't
Yeah,
like. See, another problem I had is they did not give me the material.
yeah, yeah. That physics, that textbook thing. Yeah.
Book they didn't give me.
You want that, sir? I have it. I still have it.
No, no. And another thing is the portion. In the last one, they'll reduce the portion, right? Sometimes.
Yeah, they increase this time.
Uh, so those are the things that are a bit difficult for me to manage. In the sense, I didn't like, but I knew class was not going well. But suddenly, the whatever it is, if the mark is less, the parents will also complain.
Yeah.
Fine. Let's get back to this one. Which one I should discuss now? This I have to search because this won't be relevant. These things are all are different. Relation between X and T. This is so simple. Okay, I don't know whether you have done this or you have to wait for this one. Acceleration defined as dv by dt, no? That can be written as dv by dx and dx by dt. Chain rule. Have we done the chain rule? Chain rule of differentiation. Okay. So
Yes.
this thing you're understanding or not? Chain rule of differentiation. Acceleration is dv by dt. Okay. That I can write as तो नहीं का वैल्यू क्या है 1 divided by 2x plus 1 1 divided by 2x plus 1 that I can write as dv by dx into dx by dt. You know that? You understanding or not?
What, sir?
And there are some 3 or 4 girls in your class who are not studying properly. They sit together in the middle row.
Yeah.
So how did they score in the 10th standard? Some 4 girls were there, no? Everybody here or not?
Yeah, I'm there.
No, there are some 4 girls in your class, MPL,
Who? Yeah.
who are not studying properly, no?
Who are those?
In the middle row, they'll sit, no?
The
Four
middle
girls.
row. Uh,
Gayatri on this side, the first row.
okay. Yeah.
Boys this side. In the middle row, there are some 4 girls who don't study with interest.
Yeah.
Fine. Okay, so what should we discuss now?
Okay.
No. So this graphs have they started or they about to start? Drawing graphs for the motion.
Started. They started and finished.
Okay.
PSVTTA. Sorry, AT.
So the equations of motion which you have studied, what is the important assumption in that? We have the 3 equations of motion at v equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as. Those 3 equations of motion, what are the important assumption in that? Understood my question?
Yeah.
What are the assumption in that? The 3 equations of motion.
The assumptions. Straight line parabola.
Yeah, it's a straight line motion. V equal to u plus. Acceleration is what? Can it be as a function of t, like t square? Acceleration is a number. It cannot be some variable. Okay, that is constant and uniform. What does constant mean?
Constant is.
It not change with time.
Yeah.
It's not a function of time.
Yeah.
Okay. What does uniform mean?
1 minute, sir. Just a
Uh,
minute. Sir, yes, sir.
Uniform means it will not change the space. See, I'll give an example where things will change both time and space. So, for example, in this say particular room, the temperature at this point will be say T1. Temperature at this point will be slightly different. Say it could be closer to the EC, so T2 could be less than T1. And also, so here temperature is changing with space. Okay, so temperature is not uniform. And also the temperature at the same point at a later time, say during daytime, if AC is not on, it will be higher, right? T1 during daytime and T1 during nighttime. So this function of both time also. Understood, no?
Yeah.
So in general, a physical quantity can change from point to point in space and also can change with time for the same given point. That's a general variation. But a thing which is not changing with space and time will be a number because value of G with the Earth surface, right? The value of G at this point, G at this point, G at this point, G at this point, all the points, G value is 9.8 only, the same units. And also the 9.8 value will not change today, tomorrow, or after 1 second, after 2 seconds. So it's a uniform and constant acceleration. So the three equations of motion, V equal to U plus AT, those three are valid for acceleration being a real number. That means it's not changing with time and also not changing with space. Another important thing I want to say
Okay.
is acceleration is same as force, except for what? Is this true? A equal to F? Yes or no? What
What?
is Newton's second law?
Uh,
F equal to ma,
Law
right?
of motion. Yeah.
F equal to m into a, right?
Yeah.
So acceleration is force is actually mass into acceleration, but in some sense force and mass are same because mass is just a number. Okay, so direction of force or direction of acceleration is same as direction of force
Yeah.
because direction of this vector and direction of this vector are same with both the parallel vectors, just the size is different. So similarly, mass and acceleration, so acceleration and force, the direction is same, but just the scaling factor is there, mass. So direction of force, direction of acceleration, you can understand better or easily in terms of direction of force. For example, Earth's surface, okay, gravitational force is always downwards.
Yes, sir.
That means acceleration is downwards. So for understanding direction of acceleration, just say it's direction of the force which is producing that acceleration. That is easier to understand the direction of acceleration. Mm. So yeah, obviously this static motion is a 1D motion, and I take the motion on the x-axis. So the variables of the motion of the displacement x. Okay, but along the y-axis, instead of x, we have to use y. Okay, v the velocity acceleration. Simple case. Okay, here need not be number. It can be a little bit more complicated. T is the independent variable. So the difference the graph you can draw is x versus t, v versus t, a versus t, and you can also draw v versus x because when t is changing, x is also a variable. So v x is also, v is also a function of x because v is a function of time and t is a function of x. So obviously when t is changing, x is also changing. So I can also say v and x are related.
Yeah.
So velocity is dx by dt and acceleration is how fast the velocity is from dv by dt. This dv by dt I can write as dv by dx into dx by dt. This as if you can cancel dx and get dv. This is called chain rule of differentiation. Basically,
Yeah.
to figure out how the velocity is changing with respect to time. Instead of that, what I'm doing is I'm finding out how the velocity is changing with respect to displacement, and then multiply that with how the displacement is changing with respect to time.
Oh, okay.
And this dx by dt is v, because rate of change of displacement, which is velocity. So that's where in some problems, velocity will be given as function of x. From that I can get the acceleration. Velocity is function of time, I just have to differentiate this to get the acceleration. But some problems, velocity will be given in terms of as a function of x.
Yeah.
So in that case, I have to do dv by dx and then multiply by v to get the acceleration. So first thing I'll do is I'll take the simplest motion. Simplest motion is it's not moving. It's at rest. So for this motion, I can draw xt curve, vt curve, at curve. So with the x-axis, so since it's not moving, let it be at x naught at the initial time. So it will always be here. So the trajectory is actually a point. There is no path here. Okay. So xt curve will look like this for this one. X equal to x naught for all times, starting from the initial time till now. Okay. And velocity is 0 because I'm moving. So velocity is on the v equal to 0 line. Okay. Here y-axis both x, all three x, v, and a. Okay, and acceleration is also 0 because velocity is not changing. Acceleration how fast the velocity is changing. Velocity is not changing, so acceleration is also 0. Amen.
Okay, sir.
Yeah.
Yeah.
So is this clear? For rest, x is constant x naught for all times. And velocity is 0 because it's not moving. And acceleration is also 0 because velocity is not changing. So both v equal to v and a will be 0. Okay. Y-axis I've taken all three, x, v, and a. X-axis is time. Because it's an independent variable, no? So the next complicated motion is what? Moving with a uniform speed. So now we have a path with the trajectory. As time increases, x will keep on increasing.
Okay.
So for this thing, x will be increase because x is increasing as time goes on. This is time. And it will increase as a straight line. Another possibility is increase a parabola, but here the velocity is constant. Only straight line has got the property the slope is constant. There any 2 points. So since the velocity is same, or you can say the instantaneous velocity, the slope should be same at all points that curve is line, because only the straight line has got the property slope is same everywhere. So x versus t curve should be a straight line for this motion. Is that clear? Because
Yes, sir.
Uniform velocity and also constant velocity. Okay, so vt curve will be whatever is the velocity. The slope value say v naught. That value of v naught, we have to draw the horizontal line. There's no variation because constant velocity. And acceleration is how fast the velocity is changing, which is 0 because velocity is not changing. dv is 0, dt is some value. So numerator is 0, denominator some value. So acceleration is 0. This is clear for this motion.
Yes, sir.
xt curve, vt curve, at curve. Next complication is instead of moving uniformly, I'll increase the speed. Like here it is 0, 20 kilometers per hour, 40 kilometers per hour, 60 kilometers per hour. Like that, I'll increase the speed. The initial velocity is positive. In the sense, at the starting point, I'm moving towards right because the positive axis towards right. And velocity is increasing linearly with time. So x versus t curve will become a parabola. And since velocity is increasing linearly with time, that means velocity is increasing in a straight line. That's the meaning of v linear. We can also increase as a curve. That will become complicated. Okay. First, we are doing simple things. So I'll make v increase as a straight line. In that case, acceleration will be slope of this vt curve, which is a constant acceleration.
Okay.
Okay, otherwise acceleration will become a function. Here acceleration is a real number. And this acceleration is a positive constant because velocity is increasing.
Yeah.
And slope is obviously for an increasing line, slope is positive. Slope positive means we are going up.